Hi there, it is Mrs. Tremblay again. Time for lesson 1.2, adding integers. So again, integers are positive or negative whole numbers, including 0, and we want to learn how to add them. I know that you have learned how to add positive integers. Now it's time to learn how to do the negative aspect. And this is the one where we get to use the blocks. I know, such an exciting time. So, adding integers with the same sign. Now I already know you know how to add two positives together. If this were a positive 4 plus a positive 3, you'd say, hey, it's 7. But you haven't before had to add a negative 4 and a negative 3. So we're going to use algeblocks to find each sum. Sum is a result of an addition problem. And all three of these problems, you're adding two negative numbers. I think this little algeblock mat right here is going to be very helpful. So we have a negative side of the mat and a positive side of the mat. Okay? Picture that, and you'll probably have done some of this in class. If I wanted to add a negative 4 plus a negative 3, add means combine, right? So I want to show a negative 4 on this mat. That's negative 4. There are 4 blocks on the negative side of the mat, and I want to combine 3 negative blocks with that. So I'm going to put 3 negative blocks on the mat. Now all we have to do to add is put it all together, right? So we have 1, 2, 3, 4, 5, 6, 7 blocks on the negative side of the mat. That means that a negative 4 plus a negative 3 is a negative 7. All right, next one is a negative 2 plus a negative 5. That would mean 2 negatives plus 5 negatives, which gives me 1, 2, 3, 4, 5, 6, 7 blocks on the negative side of the mat, which is also a negative 7. And the third example here, I have a negative 3 plus a negative 3. So using this algeblock mat, negative 3 looks like that, plus another negative 3 looks like that, and all together you have 1, 2, 3, 4, 5, 6 negatives. It's on the negative side of the mat. So some of you probably already understand this rule. If you don't, you need to, because if I gave you negative 215 plus negative 87, you do not want to count out all these blocks, right? What I'm hoping that you're seeing here is that if you're adding integers with the same sign, you keep the sign, and you add the digits normally, right? 4 plus 3 is 7, and we're keeping that a negative 7, because if you have 4 negatives and another 3 negatives, you have 7 negatives. Same thing here, 2 plus 5 is 7, and if they're both negative, your answer is negative, because if you have 2 negatives and another 5 negatives, they're still negative. And again, a negative 3 and another negative 3, add the 3's together, keep the sign. It's kind of like if you had 2 oranges and 5 more oranges, you have 7 oranges, not 7 apples, right? So keep the sign, add the digits normally. So I'm just going to say, add the digits, and keep the sign. It's as simple as that for that. Okay, so when the signs are the same, piece of cake. Now, you need to learn something about adding opposites before I show you how to add integers with different signs, and that's what this next little section is about. First off, any two numbers that are the same distance from 0 but are on opposite sides of 0, they're called opposites. That makes sense. A fancier word, a number's opposite, can also be referred to as its additive inverse. Okay, so opposite, additive inverse, those mean the same thing. Now I ask you again, let's use the algeblocks to find each sum. This is going to be a little bit different. So here, the first problem I have, it's different than the other one. This is a 3 plus a negative 3. So before they were on the same side of the mat, this time a positive 3 would be on this side of the mat, right? And I want to add a negative 3 to that. Now addition means that we're supposed to combine these numbers together, right? The problem is, if I combine them together and say, oh, there's 6, 6 what? There's not 6 negatives, and there's not 6 positives, right? So the answer can't be 6. There's a special thing that happens when you add inverses. Have you heard that opposites attract? I'm sure that you have heard that song. There used to be a song called Opposites Attract by Paula Abdul back in the day. It was one of my favorites. But anyhow, this negative one and this positive one, remember I said that opposites are the same distance from 0 on opposite sides? If you had a number line, here's 0. Look at this line is 0. Here's a negative 1, here's a positive 1. Those are both 1 away from 0, right? Well, when you combine opposites, they form something called a zero pair. Guess what zero pairs add up to? That's right, 0. So when you add a negative 1 and a positive 1, since opposites attract, they get married and they go on their honeymoon. They're gone. They form 0. And the same thing here, this negative 1, this positive 1, poof, additive inverse. They are gone. This negative 1, this positive 1, poof, additive inverse. They are gone. So what happens when you combine a 3 and a negative 3 is you are left with, how many blocks are on that mat? 0. All right, if I took a negative 2 plus a positive 2, do you see how I have the same number of opposites here? Poof, additive inverse, poof, additive inverse, gone. I have a negative 5 plus a positive 5. Here's my negative 5. Here's my positive 5. When you make your 0 pairs by adding the opposites, I have the same number of opposites on each side, right? So it's a big wedding here. Yup, they're all getting married. It's 5 people at the same time, or yes, 5 couples. And poof, additive inverse, they're all gone. 0. So the moral of this story, the sum of an integer and its additive inverse or opposite will always be 0. This happens because the number and its opposite create 0 pairs with nothing remaining. There's nothing left. So that's going to help us with this next set, adding integers with different signs. So we've learned that when integers have the same exact sign, you just add the digits and keep the sign. We've learned that when you add opposites, you're left with nothing. Now we're going to learn what happens when you add not opposites, but opposite signs. So in this one, I have a negative 2 and a positive 5. So getting out my little algebra block mat here. If you have a negative 2 and a positive 5, I'll put those on the mat here. Negative 2, positive 5. When we go to combine these together, because that's what addition is, I can't say that I have 7 negatives or 7 positives, right? Because I don't. But what we just learned is when you combine a number and its opposite, they cancel out. They form a 0 pair, right? So that means that this negative 1 and this positive 1 will cancel out. Poof, additive inverse. And this negative 1 and this positive 1 will cancel out. Poof, additive inverse. And I can't cancel anything else out because I don't have any numbers left on the negative side. What I'm left with is 3 positives. That means that a negative 2 plus a positive 5 gives me a positive 3. Let's try 4 plus negative 2. So there's 4 positives, 2 negatives. I don't have 6. I don't have 6 negatives, I don't have 6 positives. I do have some 0 pairs though. There's 1, 2 0 pairs, and we can see that we're left with 2 positives. The last example here, I have a negative 6 plus a positive 1. So negative 6 would be on the left side of the mat, and a positive 1 would be on the right side of the mat. It's not 7. I don't have 7 of either kind. I have a 0 pair though. I have a negative 1 and a positive 1 that can cancel out. Once I can't cancel out anything and I'm left with blocks on only one side of the mat, then I can give my answer. I have 1, 2, 3, 4, 5 negatives. So examine this here. The rules for adding 2 integers with different signs. Did I add the digits like when they were the same? No, because 2 plus 5 isn't 3, and 4 plus 2 isn't 2, and 6 plus 1 isn't 5. What did you actually do with the digits? Think, wait for it. Subtract, that's right. We had to subtract. Isn't 5 minus 2, 3? And 4 minus 2 is 2. And 6 minus 1 is 5. So if you have 2 different signs, what you're actually doing with the digits, even though it's an addition problem and this seems crazy, you're subtracting. The reason for that is because you're taking away 0 pairs when you combine them. That's why it happens. And what are you going to be left with? How do you figure out the sign? Well, you're always left with whatever you have more of to start with. So in this one, yeah, the 5 minus 2 is 3, and we have more positives to start, so my answer's positive. In this one, 4 minus 2 is 2, we had more positives, so my answer's positive. And in this one, yeah, 6 minus 1 is 5, I had more negatives to start, so my answer is negative. So the rules for adding 2 integers with different signs is, step 1, subtract the digits. So you're kind of ignoring the signs and you just subtract the digits. Step 1. After you've done that, to figure out what sign your answer is, you're just going to take the sign of the greater digit. So take the sign of the greater digit. Oops, take the sign, this is why I have you write in pencil, of the greater digit. If I wrote in pencil here, then you wouldn't be able to see it. I prefer pencil in mathematics as well. All right, we're not done yet. But wait, there's more. I have some practice problems here. What I'd really love for you to do, and I know I can't tell if you did this or not, but it's just really good practice. It says, let's practice find the sum using the integer rules for addition. Can you pause me just for a moment and try those 6 problems, and then press play when you're done and see if you're right. Welcome back. Okay, using those integer rules on the front. These are all addition problems. Some of them the signs are the same, some of them the signs are not the same. Here I have a negative 9 plus positive 2. Different signs means subtract the digit, so 9 minus 2 is 7. Take the sign of the higher digit, negative 9, I have more negatives than positives, so my answer would be negative 7. The next one, I have 12 plus negative 12. Those are opposites. When we combine opposites, it's 0. If you didn't remember that rule, and you did, 2 different signs, subtract the digits, take the sign of the greater digits, what's 12 minus 12? It's 0. And there's not a greater digit here, right? 0 is neutral. So if you forgot that, you'd end up remembering it when you solve the problem. All right, here I have a negative plus another negative. That means I add the digits, so 11 plus 6 is 17, and I keep the sign. Because if I have 11 negatives and 6 more negatives, they're not all of a sudden magically positive. I know, it's crazy. Okay, next I have 10 plus negative 7. 2 different signs. Subtract the digits. 10 minus 7 is 3. Take the sign of the greater digit. It's positive. A lot of people want to write 0 for this one because you see the same digit, but 0 happens when you have opposite signs. These are not opposite signs. These are 2 of the same sign. And 2 of the same sign says add the digits, keep the sign. And the last one, these are opposite signs. A negative 1 plus a positive 1. I'm going to subtract the digits. And there's not a sign of the greater because they're both the same. All right, hopefully you did well. All right, one more little part, and this is some fun little properties that help make adding easier for you. And who doesn't want math to be easier? I mean, everybody, right? So, first property is called the commutative property. Commutative. Say that 5 times fast. I dare you. It's really hard. It's not as hard as trying to say toy boat 5 times fast. Do that. I can't even do it twice. I'm not even going to try right now. I'll embarrass myself. I'll do it in class tomorrow. So, commutative property. Moving around the add-ends are just numbers that you add, does not affect the sum. And I think you knew this. You may not have known it was called the commutative property, but you know this. So, for example, if you have 10 plus negative 4 plus 6, if I wanted to, instead of saying 10 plus negative 4 and then add the negative 6, I could add the 10 and the 6 first, and then add the negative 4. It doesn't matter. And to prove it to you, we'll do this. If I went from left to right, 10 plus negative 4. When you add and you have one of each, you're supposed to subtract the digits, and 10 plus negative 4, so subtracting the digits, 10 minus 4 is 6, and the greater digit's positive, so it would be a positive 6. So the result of that is 6, and then when I add that 6 to it, I get 12. In this one, if I wanted to add the 10 and the 6 first instead of the 10 and the negative 4, all 3 digits are the same here. 10 plus 6, well, that's just a positive plus a positive. Just add your digits, and the answer is positive. And then when we add that negative 4, 16 plus negative 4, 2 different signs. Subtract the digits, take the sign of the greater. So we see that in both we get a sum of 12. So seriously, the order that you add numbers doesn't matter. You can add them in any order that you want. You don't have to go from left to right if it's all addition. The associative property is going to seem kind of like the exact same thing. It's a little bit different. It says that how you regroup the add-ends doesn't affect the sum. So in the commutative property, we actually moved this 6 over here, and we moved the negative 4. When you have the associative property, you're leaving them all where they are, but you're choosing to group them differently, meaning this. Let's say in this first problem, I wanted to add the 5 and the negative 6 first. Parentheses allow for that, right? These parentheses are just keeping the negative with the 6, so we know it's not a subtraction problem. I'm adding a negative 6, right? But these parentheses tell me, when you're solving this, do this side first. Or, sorry, do this piece first. So 5 plus negative 6, when you add and you have one of each, subtract the digits, take the sign of the greater digit, and I still have this negative 4 here, right? So negative 1 plus a negative 4, you have two of the same sign, add the digits, keep the sign. So the result of all of this is negative 5. Over here, if I chose to add the negative 6 and the negative 4 first, so notice these numbers stayed in the exact same place, I just put the parentheses around those first instead. This means I need to solve this first. So a negative 6 plus a negative 4, when you add to the same sign, add normally, keep the sign, I'm left with one of each. That means subtract the digits. 10 minus 5 is 5, take the sign of the greater. So negative 5 does equal negative 5, right? So that's what I'm saying. The order that you add numbers doesn't matter. If you want to move them around, it's called the commutative property. If you want to leave them where they're at, but group them where they are, that's the associative property. All right, so again, you can pause me and try these on your own, or if you're not comfortable yet, keep watching. Welcome back if you press pause. We want to use the integer rules and the addition properties to find each sum. So these are all addition. I'm going to use my addition rules and the properties to help. So in looking at this problem, yes, you can go straight from left to right. You could add the 19 and the 5 first. You could add the negative 10 and the 5 first, however you want to work it. I think this one I'll just take from left to right. So if I add the negative 10 plus a 19, one of each means subtract the digits, take the sign of the greater. I still have plus 5 left. 9 plus 5 is 14. If you wanted to add the negative 10 plus the 5 first, you could have. Negative 10 plus 5, that's negative 5, right? And I still have to add that 19. Isn't negative 5 plus 19? Subtract the digits, take the sign of the greater. 14 also. That's what I mean by order doesn't matter. There's not a right or wrong way to do this. It's doing whatever's easiest so that you can solve these without the use of a calculator. Because no, you cannot use one. I know, you're expected to do these without it. Not just by me, by the state of Michigan and many others. Okay, enough about politics. With this one, personally, I'd want to add the negative 11 and the 9 first. So I would take negative 11 plus 9, because I can do that. It's addition. I can add in whatever order I want. I just use the commutative property because I changed the order. A negative 11 plus a positive 9, subtract the digits, take the sign of the greater, is negative 2. So we're done with those. I still have to add my negative 20. When you add two of the same signs, we add normally, and we keep the sign. So negative 22 should be your answer. This next one, these are beautiful problems. I love them because I know all about additive inverses. And when you add opposites, you get 0, right? So in this problem, I would use my commutative property, and I would switch the 7 and the 8 around. So negative 7 plus 8. Because I know that negative 7 plus 7 is 0, and I'm left with 8. I wish I had my easy button. I could press it right now. That was easy. When you see opposites in there, they're gone. Simple. All right, last but not least, with this one I have negative 17 plus 9 plus 8. I'm going to use the associative property here and group those together. So I'm left with negative 17 plus 9 plus 8 is 17, isn't it? And what happens when you add opposites? You get 0. So those properties can actually make this go a lot faster for you when you have multiple digits. I'll see you tomorrow.